Okay, welcome to our 12th SunoikisisDC Digital Classics Common session. Today is the last session of the last section of SunoikisisDC Digital Classics about treebanking and translation alignment. And today we have Giuseppe Celano from the University of Leipzig. Giuseppe is a treebanker, an expert of computational linguistics, and today he's going to talk about comparing trees, an introduction to tree banking evaluation. So Giuseppe, you can start.
Okay, so thank you, Monica, for this introduction. Today I would like to briefly introduce the question of annotation evaluation, especially, more precisely, tree banking evaluation. So these slides, my contribution is meant to be a general introduction, as you can see in the title, in the sense that my goal is to give you hopefully an interesting enough picture of this complex phenomenon, so that you can then deepen your knowledge with further literature on your own if you got interested, if you like. I will also assume virtually no prior knowledge on your part, and so I will try to go step by step, so my hope is that everything can be clear. I know that Anise and Neven already talked about tree banking, and they argued that tree banking can be very useful when we try to get into the details of the grammar and of the meaning of a sentence. That's true. Tree banking is a tool, or to use a more technical term, I'd say is a formalism to describe grammar, which is kind of language independent, as Greg has also often and correctly pointed out, in the sense that whatever your native languages, we can describe the grammar of, for example, an ancient Greek sentence in the same way. And even when we cannot describe the same sentence in the same way, we can at least explain why. And we can also, which is very interesting, we can also compare analysis by different annotators, which might turn out to be a little bit more difficult if we rely only on translations, different translations in different languages, and sometimes it is also very difficult when we work within the same language, when we have two translations within the same language, in the same language. So that said, it is an important question arises at this point. How can we evaluate annotations? So this is a crucial question, because if we wanted to exploit annotations and get good results out of them, we necessarily need good annotations. The reason is a pretty intuitive. If annotations are of a certain quality, if they are not of a certain quality, we cannot rely on whatever we find querying these annotations. If data are dirty, are too dirty, probably the results will be the same. So that's why we need to find a way to evaluate annotations. We need to assess the quality of our annotation. So in this slide, you have an overview of what I'm gonna talk about. First, I will again try to say something about the reasons why we need evaluation. The second point will be how to evaluate. How can we do that? Then I will focus on tree banking and more specifically on the ancient Greek dependency tree bank, which is the tree bank that we are developing here in Leipzig. When we wanted to evaluate, as I said, because we want good data. Good data is too generic. However, another term that might help us better understand what I mean is consistency. Consistent data. Consistent is not coterminous with good. Consistent is not a synonym for good, because, for example, we can also have annotators can be consistent in making errors. For example, in that case, we have consistency, but it is not the one we are looking for. The consistency we are looking for is the one when annotators tree bank in the right way, tree bank correctly. A more technical term is reliable data. If data are consistent in the good, in the good way, then we have reliable data. But I need, before I go on, I need to take a step back and make it and stress that manual annotation is very time-consuming. And as you can also understand, also evaluating, correcting manual annotation is a time-consuming as well. For example, if we within the Prague Czech English Dependency Tree Bank project, annotators are able, they report that annotators could tree bank about 7.5 sentences per hour. This is about the third layer. This is about the semantic layer, which is the most difficult one. I can also say something about the ancient Greek dependency tree bank too, and say that on average, my two annotators could tree bank 5 sentences per hour. This includes morphology, syntax, and semantics, because we are also annotating semantics in the ancient Greek dependency tree bank too. While the annotators for the Latin dependency tree bank could tree bank about 6.5 sentences per hour. So more sentences, but in this case, they only had to annotate the morphology and the syntax. So probably the numbers can be explained because the task for the Greek annotation was more complex. I want to also to underline that these numbers are approximate numbers, because it depends on a variety of variables. It's I mean, the number, the performance of an annotator depends on, for example, the kind of text they are annotating, and also it depends on in general on their experience. Of course, at the beginning of their if they have not tree bank anything before, they will be significantly slower at the beginning. So, but this is just to get a sense of how manual annotation can be time consuming, and so also evaluation, correction of this annotation. So what's since so the manual annotation and its evaluation can be very time consuming, scholars found a way to get to a compromise, to a sort of compromise, in the sense that we want to be able to produce much data, but at the same time, we want to get good data. So how can we do that? How can we find a compromise between speed and correctness, also when it comes to evaluate annotations? Because of course we cannot correct everything manually. Otherwise, it would be like to annotate the text again. So one solution, the standard solution, is using intercoder agreement, inter-annotator agreements, which means that we choose at least two annotators. We can have more than two annotators, but at least two annotators. They annotate the same text, and then we automatically compare their annotations, and we see that okay, and we see that if they agree to a certain extent, we take these annotations to be reliable. We consider them to be reliable. And if they are reliable, we can say that they are probably valid annotations. So what I'm saying here is that, as I said earlier, since there is also agreements, annotators can also agree in making mistakes. We are, of course, not sure when we calculate agreements how much such an agreement is due to agreements concerning mistakes, errors. But still, okay, and this is an assumption, this is important to underline, still we decide that if the agreement is of a certain number, is above a certain number, and I will get back to this later, then we think that those annotations are acceptable. And so we can adjudicate them, and we can incorporate them into our corpus.
Giuseppe, I have a question about this slide.
Yes.
Because I think that it is very important and interesting, not only for tree banking. So here we are talking about agreement, and yes, yes, this is one of the challenging things we want to do in a digital environment, not only for tree banking. So
yes, yes,
agreement and maybe disagreement.
yes.
In this case, you write in parentheses to a certain extent. So in the case of tree banking, what do you mean by with this to a certain extent? And so, and another question. So there is only one possible way for annotating a sentence, or can you explain us something about that?
Yeah, I will say something about this also later, but the answer right now is that this, to a certain extent, is necessary because, of course, it is very difficult to find two annotators to always agree. Okay, so to have 100% of agreement. So we are tolerant in a sense. We accept that they can disagree to a certain extent, meaning that we know that they can both disagree because they make errors, and this is a certain kind of a disagreement, but, and this is probably what you were meaning with your question, of course, there is some kind of disagreement which is just due to a different interpretation, that might be due to a different interpretation of the text. So this is also something that it is difficult to exactly evaluate. But from my experience, I could say that, and this is something that I want to also talk about, talking about how we can get a high final inter-annotator agreement when we have precise annotation guidelines. Usually, annotators have not much freedom. Okay, they still have freedom, but the point is that if we tell them how to annotate a certain phenomenon, we should expect them to follow guidelines. And so hopefully we are trying to basically reduce the possibility of disagreements that might arise because of, for example, different interpretations, or sometimes simply because they don't know how to annotate something, and so they simply try to do their best. One way, I hope that, I don't know if I have answered your question. Okay, as I was saying, it is important to have a precise annotation guidelines, but also it is important to, for example, test the annotation, for example, using some script. This is again a standard practice within computational linguistics, in the sense that we know, for example, when we have a coordination, we usually have two conjuncts. Okay, so I can very easily run a script to check if I really have two conjuncts, for at least two conjuncts for each coordinating conjunction, and if I don't get the result that I expect, I can check and maybe correct my annotation. This is a way, another way to, of course, try to guarantee consistency and correctness within when annotating. When we have two annotators, for example, or in general, when we have annotators with no previous experience, it is also very important to often calculate inter-annotator agreements, because especially at the beginning, you can immediately identify if they are faring well or they are not, because I would say 10 or 20 sentences are usually enough to see if there are big problems with the annotation. If there is a disagreement, if there are errors, especially if there are errors, because we are humans, and sometimes you can have a perfect guidelines, but still, for some reason, annotators don't read them carefully, and so you can find errors, you can find disagreements that you can try to avoid. If you immediately detect the problem, you discuss it, and you talk to your annotators and try to solve the problems. By the way, this can also be useful for the guidelines themselves, because sometimes we can get aware of some problem. Maybe something is not clear enough, and so we need to revise the guideline or to add something. So this is, as you can understand, a complex process. So up to now, I have tried to argue that it is important to have at least 2 annotators, so that we can compare their annotations and see if they are performing well. Maybe what you might not know, I don't know, but maybe you don't know that usually within big projects, double annotation covers only part of the entire corpus, in the sense that usually only, for example, within again the Prague dependency tree bank 2, again I'm talking about the tectogrammatical layer, only about 4% of the entire corpus has been annotated by 2 annotators. So not the entire corpus, but just a part of it. Similarly, the English Web Tree Bank has been tree banked only partially by 2 annotators, 2 or more annotators. More precisely, 2.6% of the entire corpus has been annotated by more than 1 annotator. Then after this little portion of a part of the corpus has been annotated by 2 or more annotators, then usually annotators go on with single annotation, in the sense that their text is different. And again, you can understand why they do that. This is again a problem. It is again a problem with having a compromise between speed and correctness. If I have 2 annotators working with different text, of course I will end up with having more annotation than if I just employ 2 annotators, if 2 annotators work with the same text, right? But of course, this also means when there is no double annotation, that I won't be able basically to evaluate them as I could if we had double annotation. But here the logic is that, and again I think that this is a pretty clear, is that if I have, for example, 2 annotators and they are performing very well, because I calculated the inter-annotator agreement at the beginning on part of the annotation of the entire corpus, and I see and I'm satisfied with my with the results, I can assume, again, this is important, I can assume that they will go on annotating in the same way, in the sense that with the same quality, producing the same quality. So, but of course, we won't be able to prove this. This is again an assumption. So now I would like to say something about evaluation metrics concerning specifically concerning tree banking. So when we have two annotations for the same text, we can, for example, calculate the unlabeled attachment agreement, which means that we can see how many edges. If we look at the picture, I put a circle when you see the lines, where you see the lines connecting words. So we can calculate how many edges the annotators agree on. Okay, and the number would be called the unlabeled attachment agreement. Or, for example, I can just focus on labels. In this case, for example, Predco or Chord are syntactic labels, and again, I can see how many labels have been annotated in the same. So how many nodes have been annotated in the same way for labels, only for labels? Okay, so that's why label only. We call this matrix label only agreement. Or I can combine these two metrics and see how many nodes have been annotating in the same way for labels and edges. So both labels and edges. And in this case, we will have the labeled attachment agreement. So this is again a technical term. Then we can make our calculation just looking at on a word basis, so taking the word as our unit, or taking the sentence as our unit. Okay, this is usually, I can say that usually we calculate agreements on a word basis. So it is we usually calculate word-based agreement, which is also called the micro average. So this is a little bit technical. But let me now say something a little bit more specific about how we calculate these values. So the simplest way is the percentage of agreement, in the sense that I take the number of, for example, the number of labels, the number of nodes which have been annotated in the same way for labels, and then I divide them for the total number of nodes, where of course each node, so we have one label for each node. Okay, so this is the correspondence. So this is the simplest way to calculate agreement, and it is called percentage of agreement. But we can also use more sophisticated ways. For example, chance-corrected coefficients. Why? Because when we calculate agreements, we should also take into consideration the fact that two annotators can also agree by chance. So the point is that we wanted to get rid of, this chance agreement, and this is why it is also standard practice to use chance-corrected coefficients for some kinds of agreements. I just say only some because it is. I would say pretty easy to use these coefficients, for example, when we are comparing annotation for labels only, but it gets a little bit more tricky. The situation, the work is more difficult if we compared other kinds of categories which are not really really linguistic as labels are. Okay, so this is a very complex question. I would say that one could, of course, have an entire hangout and presentation on chance-corrected coefficients. I just wanted to let you know that we also have this these metrics and that they are also kind of standard practice within the field, also within the field of tree banking. Okay, so, but there are a lot of problems when comparing annotations. So, for example, I'm basically assuming that all nodes, when we compare nodes, all nodes count the same. But of course, this is not true, as you can easily understand if you have just a quick look at a tree-banked text. I mean, some kind of disagreement, what I want to say is that some kind of a disagreement might be more serious than other kinds of disagreements. But when we compare, usually because there are different ways to do that, we usually consider all kinds of disagreements in the same way. At least this is, for example, for morphological annotation, for example. So disagreements, annotating, I don't know, a noun as an adverb usually counts the same as annotating it as as a noun, but with a different case. Of course, these are two different things. But in the end, with respect to the calculation of the agreement, they count the same. And this is, of course, an open question because there are projects where they wanted to make distinctions. This is, of course, possible, but in general, in that case, calculations are more complex. You also need to always document everything, and so on. So there are different ways, but again, we try to find a compromise to be precise, but at the same time to get a procedure which is kind of fast. And another problems, and this is what Monica was asking before, is okay, which values for agreements are acceptable? Because I said that we usually accept annotation if annotators agree to a certain extent. Okay, I can say that for agreement. Usually for chance-corrected coefficients, we accept agreement which is above 80%. Okay, so this is not a magic number, to tell the truth, because I have to say that again, there is no magic number, because it depends on your project, on the kind of annotation. For example, semantic annotation is much more difficult than morphological annotation, and so we usually expect lower numbers for semantic annotation than the ones that we get for morphological annotation. So again, there is no real magic number, but in general, we look for, we try to get agreement above 80%, at least above 80%. So what about, now I would like to say something about the ancient Greek dependency tree bank, which is again the tree bank we are developing here in Leipzig. What about our text? So we have Homer and Hesiod that have been annotated using the standard method, I mean double annotation. But most of text have been annotated by just one annotator. For example, the Euthyphro or the Antigone. So what we can say about that? So this is an interesting question. What does this mean? Can we say that double annotation is inherently better than single annotation? Well, it's not really about what is better. The point is, when we have double annotation, we can at least evaluate it somehow. So the problem is that when we have double annotation, when we use inter-annotator agreement, we can at least assess, try to assess the quality of the annotation. What can turn out to be more difficult if we just have one single annotation, if we have an annotation performed by just one single annotator, because in that case we either we find a way, a test again to try to provide evidence for the good quality of this annotation, or we simply have to trust the author and thinking that since he is a scholar, because we have to say usually people annotating this text are people knowing ancient Greek, so we can expect that their annotation makes sense, but still the problem remains that if we have single annotation, it is difficult to assess its quality. While if we have double annotation, if we have two annotators, we can at least evaluate it using a standard procedure. Because, as I was saying, usually within the field of tree banking, people employs double annotation at least on parts of the entire corpus, so that they can assess, they can basically see if the annotators are performing well, and if they are performing well, then they can assume that they will go on to annotate the rest of the corpus, basically producing data of a similar quality. Okay, so and what about the ancient Greek dependency tree bank 2, which is the one I am working right now, and which is whose basic main difference with respect to the ancient Greek dependency tree bank 1 is that in this case we also have semantic annotation. So this is something new. We have up so far annotating some Aesop and some passages from the Pseudo Apollodorus, and using the standard method, so using double annotation. And what is very interesting is that in this case, I have fully documented this procedure. This is very important to stress, because usually people tend to just to report numbers. Okay, we got this, for example, we got this inter-annotator agreement, but it is not always clear how they get to that number. Okay, so in this case, for example, Monica, can you see my I open no, okay.
I saw that you clicked on the online link. Maybe you have just to close the
yes
PDF and go to the
just a second that I'm trying to wait a second.
Now we see you. And
yes, so that should be wait. Can you
yes,
wait?
now I see your browser. Yes.
Okay, wait a second, because I clicked on okay, can you see it?
Yes, GitHub, the GitHub page.
Yes. Okay, so here, for example, on GitHub, I documented the intercoder agreements that I calculated during the entire process. And for example, this is the first one, and you can see here that for each chunk of the text, I compare the two annotations, and as you can see, we get some numbers describing how much the two annotators agree. And in this case, you can also you can immediately see the difference, because we have the two sentences, the sentence of, for example, the first annotator, and the sentence of the second annotator, and then on the third and fourth columns, you see the values, the different values, so that everyone can immediately see why they are different. You can also click on the word, and you get immediately the tree. So it is even more simple, because in that case you can go on the word, and you can see, as in this case, the description of the morphology. And maybe this might be also simpler than reading this string, which requires you to know, I mean, what each letter stands for. And I did that, of course, for each layer, for example, for the morphology, for the syntax. Again, here now, I hope that you understand what I mean by micro-average, unlabeled, UAA, unlabeled attachment agreement, and so on. You can have the same for labeled attachment agreements, and again, label only agreement here, and finally the comparison for the semantic layer. Okay, and as I was saying, I documented this for each time I basically compared, and this work was very useful because as you can imagine, when my two Erasmus students started to annotate, this was pretty new to them. One of them, to be completely honest, knew something about that, but I can say that in general they had no serious previous experience on tree banking. So much was new to both of them. And at the beginning, there were errors. So doing this kind of work, comparing their annotations, allowed me to immediately detect the problems and discuss this with them, so that they could basically they could also understand the problems and hopefully avoid them for the future.
And there was an agreement in the error, so in the sense that they produce the same mistakes, so they.
Well, I didn't calculate this specifically. So the numbers that you see here are just about the agreement in general. But of course, I can tell you that after correcting a lot of these sentences, I noticed that they tend to do the same errors, but in the sense that each of them usually tend to do the same errors. So I had basically to specifically tell to each of them to pay attention to a specific problem. I don't know, maybe someone tends to confound the nominative with the accusative when they have a neuter noun. This is something that happens a lot because, you know, they morphologically are the same, and so I had basically to tell my annotator to pay particular attention to this. Okay, so now let me get back to sorry, to the slides here. Okay. Okay. So so this is again a slide, a picture of what I showed you, so here you get. Here we can visualize basically the numbers of the inter-annotator agreements that I calculated during the entire process from the beginning to the end, in the sense that the blue line shows the inter-annotator agreement for morphology, the green line, the inter-annotator agreement for the labeled attachment agreement, and the yellow line, the agreement for semantics. And as you can see, they are in general, all values are pretty high. I can say that this lower level for the label attachment agreement is due to probably to the nature of the text, because this value is about the annotation, the annotation of the syntax of the pseudo-apolloderers, which might be, simple, but it is not, because there are a lot of coordination nodes there, and it turned out that it is not that simple to understand how to put everything together. So probably this might be one explanation, but I don't know for sure, of course, because the annotation is comprises many phenomena, but that was a problematic point for sure. Then this is another visualization for for my data after just before adjudicating them, because the point is while annotating and while calculating the inter-annotator agreements that I showed, so I constantly told my annotators to correct the annotation if we detected a real error, because again, sometimes something, we can have disagreement due to a different interpretation, and that's okay, but most of the times we get disagreement due to error. So it is just an error, okay? So they had the possibility to work on their annotation after our discussion, and in the end, before adjudicating their annotations, I calculated inter-annotator agreement again, and this is the numbers that we get. In general, they are all above 80%. Only the semantic layer displays, I'd say, a borderline value here for ASOP 930. These are the numbers for the fables, because it was really about 80%. So a kind of borderline value. If we wanted to accept, of course, the 80% as the minimum we wanna in order to accept our annotations. And I can also say that I was pretty happy about these numbers, because I wanted to stress that my Erasmus students are again had no real previous experience with tree banking. So I think that I can say that they perform very well, especially if we look at the semantic layer, which is notoriously difficult, complex, and still they were able to do a good job. Yeah, so I would say that this is my last slide, and so I'm here for questions if you have any, of course.
Well, Giuseppe, thank you very much, because this was really very interesting, because you addressed a fundamental point in general for working with digital tools, so the agreement, and then how we evaluate data. This is fundamental not only for tree banking, but for many other things. So yeah. I don't know if
Yeah, I of course, as I said, I focused on tree banking, but the underlying logic can be applied to any kind of annotation. Of course, any kind of annotation needs a special treatment because there are differences in terms of evaluation metrics, but still the underlying logic is the same. I mean, we need to compare them, and we accept them if they agree to a certain extent. So this is, of course, applies to any kind of annotation. So this is right what you were saying.
And I think that as far as I understand, so a fundamental step is also to work on the guidelines, in the sense that, of course, we need guidelines, but as classicists, as philologists, we have the responsibility to work together on the guidelines, because if I understand, so we need a certain level of agreement. We need to define that. Then above that we can have a sort of disagreement, because it's impossible to have 100% of agreement, if I understand. But we need that. So if I understand correctly, so it's an important step, the guidelines.
Yes, yes, of course, because if they are precise, of course, the annotator knows what to do, while if they're not precise, so basically the annotator gets lost sooner or later, and this is of course a way to directly uh, create, so this basically is the premise for disagreement, because if you don't have instruction, if you don't have guidance, really, we can expect, so we cannot be surprised if annotators disagree, because we didn't tell them what to do, okay? So that's why I was saying that it is important to have a good guidelines, and also because, and this is something that has not to do with inter-annotator agreements, but it is still very important. If I don't know how a certain phenomenon has been annotated, because I don't find anything about this in my guidelines, when I'm looking, for example, when I'm querying my data, I get in trouble because I don't really know what I'm looking for. Because if I don't know how that phenomenon has been annotated, I cannot really perform a good query. I will just try to see if I can infer from the data how that particular phenomenon has been annotated. But again, it's like just trying. So that's why guidelines are also important, because if you give your data to another person, he should be able to understand what we did, and so query our data, knowing exactly what to look for. So this is also why we need good guidelines. Yeah.
So Giuseppe, thank you. There are many questions in the chat.
Oh,
okay. On the part of Irene and Anise. I don't know if you can read them.
No, I cannot read them. Wait a second. Oh, yes. Okay. Okay. Now I can read them. So, okay, they are very long. A little bit scared. Okay, so here we have some question from our student. Which text encoding standard do you use during annotation? During annotation process. What do you mean exactly by text encoding? Oh, is
Irene? Okay, standard.
Yeah, but exactly what? I mean, because it can means, oh yes, okay, no, okay. So we use. I have also I have worked on XML text whose schema is basically the one we have here on that we use in Perseus. So it is not a TEI XML file. It's just a well-formed XML file, and yeah, whose structure is extremely easy. And I can also say that we are working on this exactly, because this is another open question. This is a little bit more technical, I would say. But yeah, but we are not using, if you are interested in that, we are not using a TEI XML file, okay? And it is, of course, UTF-8, the encoding. Okay, then I'd like to ask a question about the words with an equal value There may be separated to subgroups according to the degree of mismatch. Some unequal values, sure, they are unequal, but still they seem to be the semantic variation of the original token. Maybe we can call them fuzzy agreement. Some words from unequal tokens are quite different, very far from the particular meaning. This is bad alignment. Do we have any measurement parameters in order to differentiate subgroup of the words with an equal value? Yeah, okay, this is what exactly I was trying to say. When you calculate agreements, of course, we can decide if we just wanted to accept those values which are the same in any features, or if we wanted to differentiate somehow. In the latter case, well, situation gets a little bit more complex in the sense that we need to usually people assign a score to all differences in order to then calculate this disagreement. I mean, you associate a certain value to the agreements in the sense that you can have, again, full agreement on full agreement or partial agreement, and you can I don't know, assign 1 to the full agreement, or just half of it to partial agreement. But this is a little bit tricky, especially for semantic annotation. I can say that, for example, for our semantic layer, this might be possible. I mean, to have a kind of scale, because so basically I have we use standard categories which subsumes other categories, so that basically we can for example accept as partial agreements two annotations agreeing only on a certain level, but not on sub-levels, for example. So this is pretty, I would say, this is feasible for our annotation. The situation is more difficult if you have categories which are not really, whose relationships are not really really clear. So the other question, we do not have a binary branching in SOSO. Each node can have more than 2 children, as many as needed. As far as I know, the final goal is to align the parallel sentences. Well, but I think that, so Irina, I think that you are talking about how we can evaluate alignments, which is another big question. I mean, this is something different from tree banking evaluation of tree bank text, because for alignments a lot of question arise. So I don't really have an answer right now, but I can only say that the situation is pretty different. I have a technical question. Which software do you use to extract numbers to calculate the agreement coefficient? Okay, so I work with xQuery, so this is based on my personal xQueries. So this is my script. Okay, if you can answer through. Okay. Okay, I don't know if we have other questions. Sorry if I'm a pretty fast in answering.
It was great. And well, we are 4 minutes late, but it's okay because we had many interesting questions, so that's why I wanted you to answer. So, well, thank you very much. It was really great. And well, next week we will have our final Sunoikis Digital Classics Common session. We don't have a topic in the sense that I would like to discuss what we have done during this semester, and then if you want, those of you who want, you can talk about what you have done with your students, because I know that you have produced data, so we can, it's just an open discussion for next week. And so thank you very much. And Giuseppe, really
Okay.
thank you.
Thank you to all of you. Thank you to all of you. And of course, I'm available for any question, I mean, via email. So, you know, you know my email address. Okay.
Yes, no, thank you. We have many different possibilities through the wiki and then, of course,
Yes,
via
yes, yes,
email.
yes.
Okay, so thank you. Have a good
To all
night.
of you. Bye bye. Bye bye. Really, bye bye.
Bye. See you next week.